Hello, YouTube. I want to show you something that's been a long-time goal for me ever since I started playing the first City Skyline and learning Unreal Engine, which occurred both around the same time in my life. I've always had a passion for a few things in nature. The first is how water moves and flows and shapes landscapes, and how it moves in unpredictable ways, like against the current at the shore. The second thing I've had a passion for is a vision for what landscapes would look like without human inhabitants. So perhaps how it appeared for the first settlers falling upon a certain area, without any buildings or dams to alter the scene that nature had already set. So it was sometimes a stretch of imagination for me to look out on landscapes and try to imagine in the old water tables and making rivers out of where cities currently were. In City Skyline, they have a fairly robust water simulator built in. This water simulator can make water flow similar to how it does in real life, in real time, changing entire shorelines or draining entire lakes based on the change of a landscape. So like for this clip you're seeing, this whole lake is flooding out into what's actually the Salt River. And all of that would have occurred simply by changing the landscape and allowing for water to flow through this path. And that happened in City Skylines too. But at the time, I thought that the engine just had some sort of understanding of how water worked. And similar to how computers handle time or other tasks, I thought water had a standard library that was pretty simple to access. So I went on in City Skylines to gather a height map of my home state, Arizona, stretching from the Gila River to up towards Four Peaks, which is where the camera's starting to close in on now. It went pretty well. I used very cheap photo editing techniques like screen capture and Microsoft Paint or Photoshop to normalize all of the height maps together so that it hides the scene, so that there was no, so that all the photos blended together pretty well. But because of the low scale that I had to shrink the entire landscape to, it made sometimes the water flow through areas that were no wider than a suitcase. And the water simulation didn't know how to handle that, so I had to help it along. So that in mind, I knew I had to, for a state as big as Arizona, I needed to create a more robust system. And Unreal Engine turned out to be the system for me, but I didn't have the water component yet. I could make a great landscape, but not make water. As it turns out, performing water calculations is pretty difficult. There are several methods that I tried. Once ChatGPT came out, it was able to help me a little bit. But one method I used was velocity fields. And that goes on the premise that water, the velocity is conserved throughout the entire system because water cannot compress. That and the Navier-Stokes equation also helps figure out where the intersections of water is, and then the Gauss-Seidel diffusion method helps with the averaging of the water. And all those systems kind of combine together to create a loose model of how water works. But unlike acceleration or gravity, there's no specific numbers that we can apply to water that's 100% correct. All we can do is create an equation that seems to accurately enough predict how the water will flow so that it doesn't get turned down by the rest of the science community. As time went on, I actually did develop a few liquid simulations using Touch Designer with the help of ChatGPT to help plug some of these complex formulas in and figure out where to put them. I was growing more and more anxious though to see a proper simulation of water because I was awaiting the release of City Skylines 2 in hopes that this would satisfy my water simulation cravings. Luckily, City Skyline wasn't the only developer that was as enthusiastic about water as they were. Christian Komisarek made an asset for the Unreal Marketplace called FluidFlux. You might have seen some of the videos going around recently. He probably created the most beautiful fluid simulator I've seen ever released on either Unity or Unreal Engine. So using this simulator, I could finally achieve my desire to both have a full-scale height map of Arizona and have an accurate water simulator to see how water flowed around Arizona and better envision it in its altered state. And then from there, the choice is up to me. Maybe I want to build a city, or maybe I want to paint a different scene around these augmented water flows. And then I had to decide, do I paint the scene procedurally with scripts, or do I go through and hand paint every detail? Or do I combine the two methods to create a hybrid approach? The adventure awaited me and FluidFlux went on sale, so I made the purchase and moved on. So this is both a tutorial and a journey of my trial and error process. I would not follow this video step by step, but instead watch my process and see which part of it suits your needs. You might find a part that didn't suit my need suits your needs, and that's why I included them. As always, your needs are probably different than my current ones. But if you want to see this journey continue, subscribe for more videos just like this, because this is only part one of my journey. I plan to add many more things to this simulation as time progresses and technology evolves. So, thank you for watching, and here is my journey. The first step is to go onto US Geological Survey, or USGS, and then you use the Extend tool to highlight the area that you want to search. You also have to check Elevation Products so that it knows what data you want to retrieve in that area. Hit Search Products and then download all of the tiles that are relevant. They are all free, and you can merge and crop all of these layers to get later together if they seem too big or too small. After that, make sure you have QGIS Desktop installed and open that application. And then go to Layer, Add Roster Layer, and under Source, add all of your downloads from USGS, and then click Open, and then Add. This warning is okay, it's just giving you a readout of the accuracy that was used in your media. You can go ahead and close this. And then what you'll see is all of these layers not normalized to each other. So they are all different brightnesses. You're going to select all of these layers and then go to Raster, Miscellaneous, and Merge. Make sure that your output type is Float32, and then be sure to add all of your layers under the input layers. You can click Select All, and it will select all of the layers that you want to add, or you can add them manually. If you've merged all of your layers and you don't see them, it's probably because your merged layer is towards the bottom of your layers. Go ahead and drag it up towards the top. And then to export that merged layer as an image, you're going to right click it, go to Export, Save As, and then leave it as raw data, GeoTIFF, and then define the coordinates that you want to export. Once you have that layer exported, go ahead and drag it directly into Photoshop or GIMP. This will bring that up in all of its pixels, and it will probably take a second for it to load. What you're going to need to do is, once it's imported into GIMP, click on your rectangle tool and then draw a rectangle over your desired area, and then hold Shift to keep it square. It needs to be square because your height map is going to be square. Then go to Image and crop to selection. And then you might be able to use this image and export it directly, but I found it really slows Unreal Engine down to have a file that size. So what I usually do is scale the image to a common coordinate, which for me will be 8K. This number will increase as time progresses and computers get more powerful, but for right now in 2023, 8K was a good compromise between performance and detail. All of the water still ran fine. Once you're done, you should have something that looks like this. It's pretty beautiful. A height map of a specific region where the highest elevation in that region is a pixel brightness of 100%, and the lowest elevation in a certain region in that same square is represented by a brightness of 0%, and every elevation in between is represented by grayscale. Now, when importing this height map into Unreal Engine, I like to create a new level instead of replacing the height map that's on the existing landscape. Be sure to add a directional light so that you can see the landscape that you add. Once you get into landscape mode, you can go to Heightmap file and import your exported image. You then adjust the overall resolution and section size to accommodate your landscape area. I don't know how big your landscape area is, so there's no real standard for this. Once you get it imported, evaluate it to see if the scale looks almost correct. You might need to increase the scale to get it to an approximate value, but don't worry about being accurate because we're going to fix that later. We're going to correct its scale once we have a proper coordinate system set up. To help see better, find a landscape texture to get you started. I like to use prefabbed ones that show cliff's edges, so in this case I use the Red Desert pack, one of my favorite texture packs. After this, I added a volumetric sky to help with lighting and make the scene a bit prettier. And then I added the FluidFlux simulation. So I found that getting this started in a small square first worked the best. Unless you have a supercomputer, I would also update the height map frequency to be something greater than 0.4. The simulation should stretch vertically around the entire landscape with a little bit of wiggle room on top or bottom. And then after you add your flux modifier source with a bit of wiggle room on top, and make sure it works in a small square, you can then move on. I maxed out my area resolution since my size was so large, and then I also adjusted my pixel size to also be what I thought was the largest they can be. Adjust your area world size to fit your simulation, and then raise your simulation just past your highest point in your map, and then use the world height to set the lowest point. Now, in this case, it didn't work because my highest point wasn't above the actual highest point of my map, which resulted in water spawning underneath the landscape terrain, and the landscape was unable to catch it, resulting in spreading water on the floor. For this case, I needed to raise the edges of my map to prevent the water from flowing over the sides, but this probably wouldn't have needed to be done if the water simulation size did not actually exceed past the edges of the landscape. And then this next part was me simply fulfilling my desire to create a massive flood coming from the north and headed south. I put on a new landscape texture and then got started on scaling the landscape correctly. This actually led way to a new coordinate system because even though I can find proper height on the Z axis, I couldn't find any locations on the X and Y axis. So I tried finding the highest point of South Mountain, which was near the center of my map. This said it was Dobbin's Lookout, but that actually wasn't the case because the highest point is actually reserved for radio towers. Heading back to QGIS, I notated the edges of the trimmed height map to its actual coordinates on QGIS, which are embedded in the downloads, and then I notated them. I figured I could make a system that knows where the edges of the map are and a central reader that lerps between these locations and the edge's coordinates, giving a readout of the real-world coordinates. It turns out I probably didn't need the edge cubes, but it helps to visualize and have that data available. This eventually evolved into setting variable values representing the edges of the map in game space, and then comparing the position of a central actor to those positions. So the total landscape position went between negative 400,000 and 400,000 on an X and Y axis. So by dividing anything's current position by 800,000 on the X and Y coordinates, I got negative 0.5 to 0.5. I could offset that value by positive 0.5, which gives me a 0 to 1 range on the X and Y axis of where that actor is on the game map. Then by using a 0 to 1 range to lerp between the actual coordinates, which was like negative 110 to 112.5, and then like 32 to 34, I can get a near perfect readout of the coordinates represented on the game map. Now I can notate the actual highest point in real life, adjust the game to match, and figure out how far off my scale is. I decided approximately I needed to scale my map double in all directions. This meant recentering my map and then rescaling the water simulator. This was an approximate guess, but the coordinate system that I devised is going to be used for probably the entire building process. After testing and seeing that the coordinate system was printing to the screen, I was able to drop all of the river starts on the map at their exact locations. This included the Agua Fria River, which is on the west side, the Gila River, the Verde River, and the Salt River, in addition to the Gila River coming down near Tucson. After that, I finally caught a relaxing break in this project and got to watch water flow down my map, which was highly rewarding. The water seemed to naturally wrap around the terrain beautifully. I believe this water flow's textures flowing through the hills like that was due to the slow update speed of the Heightmap, because after that occurred, if you go back and visit those same areas, like I think we just saw take on the screen, the water seems to flow around those better than it did initially. Now this is where I started to make a mistake. I began painting in the water level manually so that I can disable the water and then fill in the bottom under better performance. I got about 3 minutes into this process because it ended up being incredibly destructive to the environment and was ugly and was taking forever. So I changed gears. I had just done some work with depth cameras, and I knew that Unreal Engine had a scene capture 2D, which could view a scene depth in red and view a scene orthographically and render that to a texture. And all of those were good qualifications of what I need to get started, so I figured it was a good starting ground. I created a scene capture for both the landscape and the water, and then added the landscape to the scene captures for the landscape's show only list. or show only actors list, so that the landscape depth only sees the landscape and the water depth only sees the water. Now note that when you use the FluidFlux system, the water is across the entire map, even in areas where you don't see it. In areas where you don't see it, the water is simply beneath the landscape, but it is across the entire landscape. I found that by setting the scene capture to orthographic and then raising its elevation to just above the highest elevation, I don't have to compensate for the camera's distance to the highest elevation in my blueprint. By viewing the depth on the water table and the landscape separately, dividing both textures by the height's range number value, which in this case was 20,000, then subtracting the water texture, which has higher values in area where there is water, from the landscape texture, I can get a small positive value showing the water's thickness in areas where there is water. By multiplying this number by 200, I can better see the water thickness and use it as a black and white mask. To fit the mask to the map, I had to divide the texture coordinates by 8,192, which is the number that kept coming up. To test my placement, I added it to the base color of my landscape texture right before it enters the material attributes node. After that, I just had to shimmy the texture into place and make sure it was stretched correctly. Here is where I started to make another mistake. Not only was I altering the base color and not considering the inefficiency of expanding this to the normal roughness and occlusion maps, but I was also using math to remove and add textures based on their position instead of using the landscape layer blends to use more standard engine practices to layer the landscapes together. This darkness shown here was a result of using math to subtract one texture so that I can add in another. Things got progressively worse as I tried to debug this. One method I used was to apply a Gaussian blur to the water maps in order to create a beach zone. It ended up useful later, but in this current situation, it just added to the hot mess that I was creating. My approach was good because it was using black and white maps generated by the landscape's height in real time to create the textures masks, but these masks were only using the base colors. The result was unfortunately convincing enough to allow me to continue to my next set of mistakes. I realized I needed to hook up the far textures. I had a texture when the camera got close to certain surfaces, but I needed a texture for when the camera was far from the surfaces to add more diversity and breakup. Now, these textures ended up being pretty extreme, and it would have worked for like a space game or some game where you wouldn't really enter these landscapes, but for this case, the fake mountains were both hiding the real mountains and they were lying about there being a mountain there at all. I would zoom in and the mountain would suddenly go away, which was very awkward. Things got worse as I decided to use Google Maps or Google Earth to provide the ultra far textures, since they were generated by actual real-life satellites. The idea sounded good on paper, but oddly, to get the satellite imagery to match the dimensions of the height map before I even tested it, I had to shrink the satellite imagery vertically, and I did not find this satellite imagery on QGIS or USGS. Now that I had a texture for satellite imagery when the camera is very far from a location, I had to decide where to put it. I decided on creating 3 different zones based on distance from the camera, blue representing the close texture, green representing the middle, and then red representing the far satellite imagery. The result was far below what I expected. It essentially looked like I was flying through Google Earth, where you entered a video game at the lower levels. A video game with 3 frames per second, or less. And then when you flew out, it returned to Google Maps. Not only that, but I now face the problem of whether or not the satellite imagery was taken with snow on the mountains or not. And if it wasn't, then the trees have to match the texture of the middle and close ground trees. I ended up dumping this entire approach of both far and satellite imagery to just use one texture and see how that looked. It turned out pretty good from afar because of the brightness breakup that was involved. But the fact was, if I got into a middle distance on those close textures, I would see the tiling. It was this site here that actually solved the problem. What I was facing was not a matter of close or far textures, it was just tiling, which I had followed a Ben Cloward tutorial about a year ago and created this hexagonal tiling material function that rotates and scales your texture a certain amount or by a random amount to break up the tiling. The result was perfect, and you'll see it in a minute. But by using this material function, I can now use only one texture per zone's channel, so one normal map base or roughness map per zone, so desert, grass, forest, instead of having to do all that with a both near and far texture. Even better, I could use any assets pack's texture for this without actually needing to use their system. I was now using a system that I was in control of. The slope mask I decided to keep, amongst other things, because it was a nice way that they made of deciding where there was steep slopes. And it worked very well with my system being created of using black and white masks to determine where certain textures fall. Now, my initial test was all gray because I didn't delete the old blueprints and I needed to fully commit to this approach to see the results. So this is the result after that change was made. I had to skip ahead a little bit due to some missing footage, but you can see that the desert texture has correctly not tiled. It is broken up and you cannot see where the tiles are. This is Camelback Mountain, by the way. So my scale appears to be a little bit off. But texture-wise, you can see that where there's higher elevations, it turns to grass, and where there is even higher elevations, it turns to snow. Now, I have to fix the something on the snow, as it seems the brightness has gotten a little out of hand up here, which is weird because in the other areas it looks fine. Then I have a couple other issues, like this mysterious black splotch here that's not water. That's not the water level. The water level's more down here. So I'm not entirely sure what's causing that. Other than that, this is kind of how it ended up looking. I can show you the actual landscape, and that turned out like this. So my first step, I know this looks like a lot, some of it's not used. My first step is to use the landscape depth and do a bunch of math to create a bunch of different masks, which are actually only viewable if you can plug them into the emissive color, because if you try to preview them, it won't show. So for the terrain, I have, I think, 3 layers made. The first is where there is sand. Second is as according to the Yuma desert, not water. And then there is where there is desert, and then where there is snow. All 3 of these layers come down here, and then I create my material attributes by using this hex texture that Ben Cloward has in his tutorial series. I create the entire material attribute, and rather than using the black and white mask alpha layer to blend the base colors together, I blend the entire layer together. So this all was left after the Great Delete by me. The Great Delete being everything, all of the textures, or yeah, most of the textures that were used to create the landscape. So this is the default flat texture, and this is the default cliff texture. Both of those alpha layer together with a slope angle to create the default texture. From there, I can choose to layer over that texture. So here in this first one, it blends with the desert texture as according to the desert mask. Next, I blend in with snow, and then after that, I blend in with sand. After all of that, I then blend in with where there is water. And for my water textures, I have 2 sections. The first is a blurred water texture. So I first divide my texture coordinate by the map size, which I found that number to work. And then I set a small number called kernel size. So this dictates how big the blur is. So in all 4 of these instances, I am subtracting my water from my landscape texture, and then shifting that up, down, left, and right, adding all 4 of those together, and then dividing that number by 4, or dividing that texture by 4, so that my result is a sort of blurred out water method that sort of represents where the beaches would sit. This has to get fed into some of my terrain because I can't plant saguaros where there is trees or where there is water currently, even though that still persists even though I subtract it. Same with bushes. I also have a water texture that's not blurred, and that's a little simpler. That is just the water texture minus the landscape texture. And again, I don't have to use the offset anymore, so that's zeroed out. I'm going to delete that eventually. And then all of this combines to blend sand where there is water as the bottom texture, and then I break those material attributes, and then so that I can do any post-processing on them, which is useful for testing the maps, and then send it to my landscape. That is all of it. There is also a brightness macro variation that was left behind, and I believe this is what's responsible for this snow issue over here. But time will tell that. So that is how the texture part turned out. Now for applying foliage, it's actually a little simpler than I thought. All you have to do is, in your content drawer, right click, go to foliage, landscape grass type, and then I'm gonna call this one test because I already have test going. Double click it, and then you're going to add a grass variety. Now this takes a static mesh, so what you might want to do here is go to your foliage pack and then turn on a static mesh filter. This will give you only the static meshes. From here you can apply this to your grass mesh and then adjust all of your parameters. Now, I don't want to add a bunch of cattail right now, so I'm not going to actually add this in, but I'll get close. So what you want to do, obviously save that asset that you just made, and then go to your landscape. Where is my landscape? And then find your landscape material. And in your landscape material, you're gonna use, this is gonna live probably right next to where you generate your masks. And the reason for that is because all the landscape takes is a black and white mask. So you can see here I have my saguaro mask and a trees mask somewhere right here. And those are the only landscapes that I've added so far. The grass right now is everywhere, which has to be fixed. And then the saguaro mask and the bush mask get subtracted by the blurred where's water mask and then plugged in. And all you have to do is add a little plus thing here and then assign this to the landscape type that you just made. So the test 1, and then you would put a mask in. So if I were to change this to 1, save this, and save this, theoretically I should see cattails come up across the entire environment. So let's find out. Yes, I did. There's tons of them. And then likewise, if I go back to this landscape, change this to like 0.1, it would probably give much less cattail. Which is what it did. So then you can, instead of adding a raw number in, you add a mask and it decides where to put those. You can see the saguaros don't really go up to the higher elevations, which is accurate. So that is it so far. I'm going to add more to this, but this was my little journey to explore various mountains like Superstitions and Four Peaks and where's Camelback? That's Scottsdale Mountains. Camelback. And just do something different. Let water flow over things and try to replicate natural beauty. Thank you for tuning in. I will be back with more. Adios. So thank you everybody for watching this process. I don't know where I'm going to go with this project exactly. I have a vague idea. After the waterways get created and dams get created and foliage and scale is correct, I would like to add more life to this than plants and water. I I would like to add wildlife that roams in certain biomes, and I would like to eventually add roadways. Now, AI is coming along pretty fast, so I would hope that I would not have to manually add in all of these roadways, and this could be something more scalable where I could bring in a map and then have the roadways generated while I just specify which ones are freeways, main roads, or side roads. That would be ideal, and I would like to progress further with this map of Arizona, building it in procedural ways that I can clone over to other environments. I really enjoy working with water type environments. I wouldn't mind doing only land type, but using this water simulator opens up a lot of different map possibilities, such as New York or watery parts of the beach. And for now, I'm going to keep working with Arizona. It's my hometown. Some of the landmarks around here I recognize. I enjoy looking at and seeing things like the Superstition Mountains as I go around and do my things. Obviously, there is a lot of improvements to be made. Some scale is too tall, it seems. Some scale is too small. And it appears there are saguaro cactuses being flooded in what could or could not be a flood zone. But I enjoy working with water, especially in the desert. I think it's interesting that humanity has been around water since our entire existence. We need it to stay alive, and technology has come so far in the time span that we've been around it. And yet we're only recently beginning to be able to visualize and predict water in computers. I do want to get AI a bit involved in this project. I think it could help a lot, especially when I want to roll it over to other cities eventually. For placing landmarks like mountains and especially caves where terrain won't be able to sculpt around. Terrain can form up to a certain point, but cannot form caves or underground passages. In addition, I can bring in NVIDIA nerfs, which are essentially drone 360 shots of hopefully mountains. It works better with mountains because it uses AI. And all you need is a drone video around a mountain to create a 3D model of it in almost perfect texture. What is lacking, you can use height data to fill in. And I would like to add those to landmarks like Red Mountain, Weaver's Needle, some parts of the Superstitions where it gets really detailed, and just have fun with this. But make it as procedural as possible and yet as beautiful as possible. I might even do some randomization just to mix things up. Thanks for tuning in and watching this video. If you liked what you saw, please let me know in the comments what you liked about it or what you want to see more of. I don't really have a model for this project, so if you want to add some input, I would love some input at this phase of development. It would mean a lot to me to have some conversation with everybody, so yeah, I appreciate any feedback that you guys can give. And if you guys like what you saw, give it a like. If you guys want to see more, hit that subscribe button, and I will be back for more with this same map and hopefully many more. Good night, everybody, or good morning, or just have a good day. But whatever you do, do it well.